In this episode, we are going to explore the Dudh Kosi River and its larger watershed. The Dudh Kosi is not a river that regularly comes to mind when one thinks about the world's great rivers. So why are we looking at this river? The primary reason for doing this river is because it is the watershed to which Mount Everest drains. Therefore, the Dudh Kosi River is the highest watershed in the world and has the most fall between the top of the watershed and its final ocean drainage. The Dudh Kosi River basin lies in the Himalaya mountain range, spanning Nepal and Bhutan. China lies to the north of the watershed, with India lying to the south. The total catchment area is 3,712 square kilometers. The Dudh Kosi is also called the Milk River because of its frothy, cold, white water. It is classified as a whitewater river, although it's not generally recommended for paddling because of the speed of the water. That being said, there was a whitewater expedition in the 1970s by some particularly adventurous souls. The Dudh Kosi lies within the larger Kosi River Basin. The orange star in the middle of this image shows where Mount Everest is within the larger watershed. The Kosi River Basin flows in a southerly direction through the Himalayas. The upper portion of the basin drains 7 smaller watersheds to a single point known as the Chatra Gorge. From this gorge, the watershed drains into an alluvial plain at the base of the mountain range. The complete Kosi River Basin drains an area of about 74,500 square kilometers from the countries of Nepal, China, and India. The Kosi River Basin is part of the larger Ganges River system, which eventually drains into the Bay of Bengal, which is part of the Indian Ocean. So while the Dudh Kosi watershed is a fairly small system in terms of its overall size, it is a river that contributes to a larger watershed that is of value to more than 1 billion people. Therefore, I feel it is appropriate, outside of being the highest watershed, but also because the number of people it could influence to consider the Dudh and the larger Kosi watershed to be one of the world's great rivers. The upper Kosi system merges at the Chatra Gorge, which is a deep system coming out of the Himalayas. While the gorge is cut by erosion, one of the fascinating aspects of this gorge is that it predates the development of the mountains. As the Himalayas kept pushing upwards, the river kept cutting downwards, creating an amazingly deep valley. While the Kosi River system is an old system, it is carving its way through a relatively young mountain range. The Himalayas started forming around 50 million years ago, when 2 tectonic plates, the Indian and the Eurasian, crashed into each other. As the Indian plate migrated to the north and the Eurasian plate wandered to the south, neither one was going to scooch out of the way of the other. Therefore, they crashed into each other. As they were both made from roughly the same material, they both buckled, pushing up the land within their zone of contact. As these 2 plates are still pushing against each other, the Himalayan mountain region continues to grow in height. It is growing at an average of around 1 centimeter per year. In geological terms, that is a sprint towards the sky. If this pace were to continue, the range would grow 10 kilometers in a million years. I know that seems like a long time, but we are speaking in geological time frames, so this really is a mad dash upwards. Most of the water comes into the Kosi watershed from monsoon rains that occur roughly between June and September. These monsoon rains come up from the south, so the southerly portion of the watershed gets between 1,500 and 2,500 millimeters of rain per year. As the Himalayas create a rain shadow, the northern part of the range gets around 300 millimeters of rain per year. So it really is 2 different watersheds, depending upon which side of the mountains a person finds themselves on. The highest parts of the watershed, including Mount Everest itself, is covered by a perennial snowcap. This snow is refreshed during the monsoon season, so one will always find snow on the peaks. A few years ago, Chinese climbers tested the snow, and they found 11 feet of snow at the very top of Everest. So that is a fair bit of snow. All the snow that falls on top of the mountains works its way downwards by melting and ice creep, forming glaciers throughout the mountain range. Within the larger Kosi watershed, there are over 1,000 glaciers that hold an estimated 276 cubic kilometers of water. However, these glaciers are at risk due to climate change, and they are retreating each year. As these glaciers provide a substantial source of water downstream, the retreat and loss of the glacial water storage is a significant concern. As the headwaters of this system is based upon glacial features, there are some unique threats in terms of potential flooding. Excess rainfall in the headwaters can create devastating downstream floods. However, with the glacial features, there are also glacial lakes and landslide dams that can pose substantial threats. While the glacial lakes are not like Glacial Lake Agassiz, and please do look at that video, the breaking of a glacial or landslide dam can send massive amounts of water into the lower reaches with no warning. As can be expected in a mountainous region, the vegetation within the Kosi watershed is based upon the amount of precipitation that reaches any particular site. The Himalayas are a massive mountain range that blocks much of the water from the monsoon range from crossing to the north. This creates very different ecosystems on the north and south side of the range. With the northern part of the watershed being in the rain shadow of the Himalayas, it supports a more drought-tolerant vegetation assemblage dominated by grasslands, bare ground, and glaciers. The southern part of the basin is more diverse due to more rainfall. There are more forested areas, and we begin to see some agricultural production in the lowest portions of the watershed. While there are people living throughout significant parts of the watershed, built-up areas are few and far between. Throughout the entire watershed, built-up areas occupy only 0.03% of the land cover. This is a tiny amount for a watershed area. As the Kosi watershed serves as a critical source for drinking and agricultural water to the downstream communities, it is important to understand the potential water quality concerns that can impact these downstream areas. In the Kosi watershed, scientists test three parameters to determine water quality. For the physical and chemical parameters, the river is generally in acceptable condition, meeting drinking water standards. When we discuss a generally acceptable drinking water standard, we are not recommending that one dips a cup in the river and taking a drink. But when using a minimal standard of filtration, the water will be generally good enough for human consumption. While the physical and chemical water quality parameters are within acceptable tolerances, those associated with biological activity are not doing so well. One physical standard, that of turbidity, which is discussing sediment and other suspended material in the water, does not meet standards. For biological activity, E. coli and other coliform bacteria also exceed standards. For each of these parameters, the level of these contaminants in the river is above what is safe for human consumption. The primary contributor to these impairments is human activity. Improper disposal of waste and the lack of sewage treatment has been identified as the principal causes of these impairments. With the remote location of many of these smaller communities and the dispersed nature of people within the watershed, finding the funding and creating effective systems to treat these problems is going to be difficult. With the Kosi watershed being significantly dependent upon monsoon rains to provide water, the basin is particularly prone to periods of flooding and drought. During the height of the monsoon, very high amounts of water can fall within the watershed, which quickly flows down the steeper regions until it hits the flatter areas of the basin, where it leaves the channel and floods the surrounding region, destroying crops and inundating communities. On the flip side, when the monsoon ends, the rain stops, and the once abundant water can become scarce, which can produce extreme hardships as people need to go further to get even their basic daily water needs met. The very headwaters of the Kosi watershed are the glaciers at the top of the Himalaya mountains. While these glaciers have provided water for thousands of years, they have been retreating in the past, declining in size at an alarming rate. As these glaciers shrink in size, they become less of a reliable source of water, further contributing to potential droughts in the downstream regions. This sequence of images over several years shows the potential effects of climate change on a glacial field. While this is not in the Himalayas, it does provide an example of what may be in store for this region. In addition to glacial retreat, the warming of the climate is likely to make the monsoon season more severe and the dry period drier, which can result in even more flooding and worse droughts. This region of the planet is incredibly complex and crosses many international boundaries. Therefore, effective long-term management of the region cannot be left to one party. In order to facilitate the protection and development of this region, the 8 countries within the Hindu Kush Himalaya region have come together to form the International Center for Integrated Mountain Development to increase understanding, share knowledge, and plan and implement activities that benefit those living within this area. Within the larger partnership, the 3 countries within the Kosi Basin watershed, India, China, and Nepal, have come together to create the Kosi Basin Initiative to focus specifically on the concerns and challenges within the basin. The primary goal of the Kosi Basin Initiative can be documented in a few words: improved water resource management in the Kosi Basin and enhanced livelihoods through evidence-based decision-making and basin-wide cooperation. While these are just a few words, we should not let them mask the enormity of the task they are trying to accomplish. The Kosi Basin is a complex ecological system about which we are constantly learning. Adding people to the mix adds an additional level of challenge, and then spread that across 3 nations, and the tasks could seem insurmountable. However, there is hope, a lot of hope. Within the larger initiative, there are 5 interlinked components through which the partners are working. These include developing a knowledge base of the region and its dynamics, exploring ways to manage water, agricultural production, and the development of hydropower within the changing climate, reducing the hazards from flood and drought, finding ways to help communities adapt to the region in which they live and improve their local livelihoods, and finally, this effort is aimed at working through an integrated response of the partners. While the challenges of achieving the goals of the Kosi Basin Initiative are large, the partners have come together to make some substantial improvements in the management of the system and develop some effective conservation and protection strategies. These efforts are a combination of using modern science while incorporating the input of those living and working within the system. This combined approach is a powerful tool for ensuring that any proposed actions are supported locally. With the incised channels and fall of many of the streams and rivers within the Dudh Kosi subwatershed, it is a natural site in which one could consider installing hydropower dams. The Asian Development Bank conducted a study in 2019 and identified several potential subwatersheds in which the conditions are suitable for the development of hydropower projects. However, these projects are not without challenges and risks. While hydropower could be an important tool for development and conversion to a climate-friendly energy, there are local and regional challenges that will need to be addressed. One of the principal barriers is the lack of infrastructure within the region, in which large-scale construction projects can be implemented. Roads would need to be built to the site, and then an energy system would need to be built to carry electricity from the dam to users. In addition, converting the system to hydropower production will influence agricultural production through the possible elimination of diversion channels that irrigate crops. Dams are also barriers to fish migration and pose significant challenges to maintaining a functioning aquatic ecosystem. Finally, as the watershed spans 3 nations, there would need to be the development of cross-boundary partnerships to ensure the benefits are distributed and no one entity is significantly harmed during the process. Starting at the top of the world, on the peak of Mount Everest, the Dudh Kosi falls through the Himalayas before finally entering the Ganges River system. While the Dudh Kosi is not a large watershed, and the streams and rivers that make up the larger watershed would likely not be individually seen as great unto themselves, their connection to Mount Everest and the Ganges River makes this river one of the world's greats. We all should know a little bit about this river that stretches from high to low, and now you do. Thank you for watching.